Hello everyone and welcome to this GeoStru software video tutorial. GM3D software is used for geological and geotechnical beam modeling which, through 3D modeling algorithms, is able to reconstruct the three-dimensional stratigraphic model of the subsoil. In this video, we will see how to build or import topographic surface and surveys, how to build a 3D model, and how to export the results in PDF, DWG or the XF format. First, let's see how to work on the topographic surface. We work on the topographic surface by importing it through a text file with CSV or GMD extensions, or by manually inserting the points. To import the topographic surface, we can select the file to be imported and drag it onto the topography node, or right-click on the points table and then on Import Topographic Surface. Once the file is uploaded, we need to specify the coordinates format. For better workflow, it is recommended to leave the Axis Translation checkbox checked, the settings that bring the imported surface closer to the local origin of the reference system. Clicking Continue will draw the chosen surface. We can also manually insert the points with a right click and then choosing Add Point and consequently entering the XYZ coordinates of the point and possibly a node. Each point entered can be edited or deleted by right-clicking on the point and then choosing Remove or Edit. The same operations can be performed through the table that is displayed by clicking the Topography node and then on Refresh Points. To derive a topographic surface, we can choose to use GeoStru Maps, one of the GeoApps made available by GeoStru. To do this, simply connect to GeoStru Maps, locate the place for which you want to obtain a topographic surface, and choose the points to export. One way to do this, in addition to selecting the points individually, is to choose the 2 points, click on Calculation, select Mesh, and then choose the number of rows and columns of the grid of points we want to make. Once the grid is displayed, we can choose whether to export it manually or add more points. At this point, by clicking on Export, we can choose the export format of the point's coordinate and save the file. The exported surface can be imported into GM3D as seen above. After loading the topography, we can check the points on the surface by clicking on Check Topography. With this option, the topographic surface will be corrected, if necessary, in order to optimize the 3D model. Also, in this case, it will then be possible to delete, add or modify the points of the imported surface. Creating, editing and importing boreholes is handled quite simply. Let's start with how to create one. To do this, we can choose Add Borehole by clicking on the space on the topographic surface or on the borehole node. At this point in the Details menu, we should enter the borehole code for the name that will be displayed, a description, the coordinates of the borehole, and from the stratigraphic table the various layers of the soil by entering the progressive depth of the layers, and for each layer choose the type of soil. Clicking Apply will be the 3D model of the borehole. To each borehole, we can assign the results of an in-situ soil test. To do this, we just click on Borehole, choose Add Test Results, then Import. At this point, the graphic of the test will be displayed in the Details menu and next to the borehole. To import one or more boreholes, simply click on the borehole node and choose Import Borehole from EDP file, then select the borehole to be imported and click Open. As we have seen also for the topographic surface, it is possible to drag one or more EDP files on the borehole node. If we import a number of surveys greater than or equal to 3, the top points will be connected automatically and the topographic surface will be created. Once the boreholes are imported, we can edit the surface by entering points manually by clicking on the surface in the surrounding space or through the table, or by importing the topographic surface file. Once imported or created, boreholes can be moved or edited. For example, by clicking on a survey and choosing Move Borehole, we can choose the plane on which to move or relocate it. Once in the new location, the topographic surface will also be updated automatically. A borehole can also be copied and pasted. So click Copy Borehole and then Paste Borehole to paste it to a generic point, or paste borehole on point if you want to paste it to a specific point on the topographic surface. Obviously, boreholes can be exported, edited and removed. To edit a borehole, we can select it from the 3D model or from the Workspace menu and change the settings from the Details menu. We can change the name, description, location or add, edit and remove layers. Let's go back to the examples used so far and try to import the topographic surface and surveys and create the 3D model. First of all, even if it's not necessary, we import the topographic surface. We step in this case, the topography in question has been exported through GM3D, so it will not be necessary to leave check the box Axis Translation. Once the topography is imported, we also import the boreholes and click on Generate 3D Model. At this point, we notice that in the Workspace menu, the Layers folder has been created, which contains the information of each 3D layer. Selecting the various layers, this will be highlighted by the 3D model, while in the Details menu, we can set and view the geotechnical parameters of each layer. By clicking on the edges, we can choose whether to show or not the edges of the model, while with transparency, we can make the model transparent. By clicking on Show 3D Surface, we can view the surfaces of the various soil layers. Once the model is created, by clicking on Section, we can draw lines along which we are going to create sections of the model. Another way to make sections is to click on Clip, which will generate a plane through which we can see inside the model. Once we have found the point where we want to make the section, we can click on Capture Section. To view the created section, we can click on Show 3D Sections. Moreover, selecting a layer from the Workspace menu, we can view the 3D of the single layer, or for example, the single layer of the drawn sections. To view the sections individually, we can click on the single sections within the folder, or with the right button and choose View 2D section. Finally, the created template can be saved by clicking on Save As. Once the template is created, we can export any view in PDF format. To create, for example, the table for a section, we can pass the 2D view of the sections and from the home bar, click on Print in PDF. At this point, a table of the section will be automatically generated in PDF format. The same operation can be done for any other view of the model. The entire model, as well as individual sections, can also be exported in DWG or DXF formats. For example, to export the model in DXF, we have to click on Export DXF command from the home bar. After saving the file in DXF or DWG formats, we can open it in different softwares as CAD software and switch to a three-dimensional view, such to be able to better appreciate the model. And we notice that together with the model have been exported all the layers connected to all the present elements. Therefore, we will have a layer for the boreholes, a layer for every layer, one for every section, and so on. In this video, we have seen what are the general characteristics of GM3D software, or how to process the topographic surface, then how to get it through GeoStru maps, and how to build it inside GM3D. We have also seen how to build boreholes and how to import them using files in EDP format, which is a well-known GeoStru data interchange format that allows the export and import of data related to static, dynamic, and geophysical tests. Finally, we have seen how to realize a 3D model and how to export the processed data in PDF, DWG, and DXF formats. Thank you all for your attention, and see you soon in our next video tutorial.